What was that periodic table shape based on?
Electron configuration?
I heard the word similar. I didn't hear what you said.
Is it electron configuration? Electron?
Yeah, it wasn't based on electrons or electron configuration. Do you remember why?
It's even, it's this Hibberescent.
Dmitry Mendeleev didn't believe in electrons. He created the table before the electron was conceived. But sorry, what'd you say, April?
Oh, I was saying the same thing.
No, about the shape of the table.
Oh, I was saying, it's based on sorting things by their similar.
Okay, so grouping elements based on so it's based off of elements having similar chemical reactivity. So if you're in the same family or the same group, meaning the same column, then you react similarly to everybody else in that column. But see, we're talking about chemical reactions, right? And based off of what we've talked about so far, a chemical reaction is fundamentally what? Electrons. So when Mendeleev came up with his table, it was based off of the reactivity, but since reactivity is based on electron actions, it's all about the electrons, right? How many energy levels exist, and how does that relate to the table? 7, and there are 7 rows. Okay, and the sublevels? Yeah, so the sublevels is also 7 sublevels. You need 7 sublevels because the 7th energy level has 7 sublevels in it. So those 7 sublevels are S, P, D. What else we got? Okay. We really only care about those first 4, though, right? And what was the reasoning behind that? All the atoms, the largest atom that we've got doesn't have enough electrons to actually fill up any of those G, H, or I sublevels. Okay, how many electrons fit in an orbital? 2. Every single one, I can only get 2 electrons in there. So I just need to know how many orbitals are in a sublevel, and then I can figure out the number of electrons. So which sublevels are found in the second energy level? S and P. And why is it 2? The second energy level must have its number of sublevels. Well, really what I should say is, let's get rid of this. Let's just say energy level must have its number of sublevels. So if I'm talking about the second energy level, I must be talking about 2 sublevels, and the first 2 sublevels are S and P. So how many electrons fit in that 4th energy level? So based off of this last question, how many sublevels do I have in energy level 4? 4. So 4 sublevels, and the sublevels are S and P and D and F. And so there's 1 orbital there, 3 orbitals there, 5 orbitals here, and 7 orbitals here. So that means I've got 2 electrons here, 6 electrons here, 10 electrons here, and 14 electrons here. So I end up with 32 total electrons can be found in that 4th energy level. Is that good? Okay, electron configuration, colon 1s2, 2s2, 2p3. Can you give me 2 ways to verify that's probably correct? So 2 plus 2 plus 3 gives me 7 electrons, and nitrogen must have 7 electrons in it to be an atom. And then what's the other way? The last electron is in 2p3. So that puts it in the second row, the p block, and then the third column over. And if you go to the p block, go to the second row, and go 3 columns in, you find nitrogen. So now I've got sulfur, 1s2, 2s2, 2p6, 3s2, 3p4. 4? You good with 4? It's right below oxygen, so it's P4. And then you see 2 and 2 and 6 gives us 10, and 2 more, 12, and 4 more, 16, and sulfur's element number 16. And it's in the third row, the P block, and the 4th column over. All right, so 1s2, 2s2, 2p6, 3s2, 3p6, and this is where it gets weird, right? I put electrons in that 4s before I put electrons in my, oh, that was weird, in my 3d. And how many do I need? Okay. Alrighty. And then this last one about Heisenberg uncertainty principle. Okay. I like that. That's a better phrase. The act of so just looking at it moves it. So I can't see it because it's not where it was a second ago. Did anybody find the actual definition? So you can't know the position and momentum of an atomic-sized particle at the same time. So I could know where it is, but I don't know how fast it's going, or I could know how fast it's going, but I don't know where it is. So, I mean, you guys look at a car, and I see it's moving 25 miles an hour down 13th Street, and it's right there. But that's because when the light from the sun or headlights hit that car, it doesn't throw the car into the yard next to the street, which is what would happen with a subatomic particle or an atomic-sized particle. Okay.